The assignment of signal integrity models to schematic parts enables electrical topology extraction of schematic nets to perform SI analysis and exploration with OrCAD SI. Signal integrity models can be set up quickly and easily for the entire schematic design or a targeted net. To speed up and help automate the model assignment process, the Auto Assignment feature in OrCAD Capture provides automated model assignment for discrete components throughout the design. This eliminates the time and effort that would be required to assign models for passive devices manually. If models are not assigned to parts on the schematic, the extracted electrical topology of a net will use the default I/O models based on the part pin type. It is always more accurate for analysis to assign package models which include package parasitics into the simulation. The model assignment interface allows easy management of signal integrity model assignments for selected parts and pins. The part model assignment interface provides a quick selection from a library of package models. The assignment operation automatically validates the package model with the part on the schematic to help prevent errors which would be encountered later. The package model assignments between drivers and receivers enables electrical topology extraction for all the data nets and differential pairs between two ICs. In the absence of available package models, default I/O driver-receiver buffer models may be used for close approximation during signal integrity analysis of critical nets. I/O buffer model assignment on the pin of a clock generator allows electrical engineers to simulate the clock net for timing. A signal integrity expert can use package models on the clock net for more detailed analysis to complete the design for this critical net. With these simple steps, the schematic is populated with all the necessary data required for pre-layout signal integrity analysis and exploration. Front-end engineers can extract electrical topologies from schematic nets for signal integrity exploration and verification. To ensure the quality of a signal from a driver to one or more receivers, these extracted electrical topologies can be simulated with OrCAD SI to determine the correct physical properties and high-speed constraints. In this example, a very common design scenario, a driver IC and receiver IC are both synchronized with a common clock signal. The data signals from the driver IC to the receiver IC include single trace signals as well as differential signals. The Explore Signal menu pick in OrCAD Capture will extract the electrical topology for the selected schematic net. Upon extraction, the extracted electrical topology is loaded into the Signal Explorer tool automatically, ready for simulation, optimization, and constraint definition. The same process will extract an electrical topology from any net on the schematic, including differential pairs. The topology extraction process exports differential signals along with the driver and receiver buffers. Once extracted, the net topology can be simulated and analyzed for signal integrity issues and constrained for first pass success. OrCAD SI provides a comprehensive signal integrity solution for the exploration, validation, and constraint of critical high-speed nets. Exploration of critical high-speed nets can be performed with simulations of swept parameters, different topologies, and termination strategies, creating an environment for fast and easy what-if scenarios. The result of these simulations are plotted in a powerful graph plotting environment, SIGWAVE. Net topology elements such as vias and strip line or microstrip transmission lines can be modified or added to achieve performance or characteristics. Connectivity of the topology can also be edited to include new components. A T is automatically inserted when more than two transmission lines are connected to each other. For what-if analysis, a range of values may be specified for one or more components. In this case, the resistor value is swept from 30 ohms to 70 ohms in steps of 10 ohms. OrCAD SI provides a number of stimulus setup options. We are using a 100 MHz signal with a 010 bit pattern for this simulation. OrCAD SI simulates over a range of parametric sweeps swiftly, calculating the configured measurements for each simulation run. One of the commonly used measurement values is noise margin. This allows for quick filtering of unacceptable cases. The simulation results for desired measurements can be selected and viewed in SIGWAVE for more detailed analysis. Based on the simulation results, constraints may be defined for the electrical net. OrCAD SI supports many different types of constraints from simple to complex. A relative propagation constraint may be specified globally for all driver-receiver combinations, or a propagation constraint may be specified for specific drivers and receivers of the electrical net being explored. From a simple wire length constraint to a complex user-defined constraint, constraints can be grouped and added to the electrical net in the form of an electrical constraint set. These electrical constraint sets are subsequently available to signal integrity experts for further detailed analysis and to PCB designers to ensure timing and signal quality in the physical layout. Electrical net topologies designed with high-speed constraints in OrCAD SI may easily be assigned to schematic nets in OrCAD Capture. First, this ensures the topology connectivity matches the schematic net, and second, the electrical constraint sets defined for the net in OrCAD SI are associated to the schematic. This allows critical or high-speed net topologies and constraints to be available for transfer to a signal integrity expert for validation or a PCB designer to drive physical layout. The process of associating a topology from OrCAD SI to an OrCAD Capture schematic net is simple and straightforward. A save of the topology and a single menu click to update Capture. The Capture schematic receives the topology data from OrCAD SI and validates it. Whether it is cost-driven consumer applications or performance-driven design architectures, the demand for increased performance is accompanied by higher edge rates that result in significant signal integrity challenges. As the percentage of design nets requiring signal integrity analysis goes up, it is unrealistic to expect to have signal integrity experts design all the nets on a board. It is also unrealistic for every design engineer to develop signal integrity expertise. Typically, design nets get categorized into signal integrity critical, which require the attention of signal integrity experts, and signal integrity significant, which are more easily constrained by electrical engineers. The example we have seen so far highlights OrCAD support for the direct exchange of electrical topology data between OrCAD Capture and OrCAD SI. When working with signal integrity experts, OrCAD provides support for an electrical engineer to capture constraints on critical net in OrCAD SI and export the electrical topology data for transfer to a signal integrity expert. The Export Constraint Set function provides an easy interface that can be used to select electrical constraint sets for expert. The OrCAD SI flow provides unique capability that allows electrical engineers to work directly on signal integrity significant nets and collaborate with signal integrity experts on signal integrity critical nets. All the constraints designed in the schematic by the electrical engineers need to be passed to the PCB designer for layout. In OrCAD Capture, the PCB netlist process using Create Netlist generates the netlist and automatically transfers the electrical net topologies along with the constraints over to PCB Editor for layout. PCB Editor has an integrated constraint manager tool to assist in managing electrical constraint sets for the nets in the design. In Constraint Manager, all the nets we had constrained in the schematic have an electrical constraint attached to them. The detailed electrical constraint set definition can now be imported into Constraint Manager. The electrical constraints are now available to the PCB designer. Constraints designed for one bus member can easily be copied over to other bus members. The PCB designer can now use the information provided by the logic designer for component placement, pre-layout analysis, and post-layout verification. Constraint Manager allows PCB designers to view, refine, and validate constraints received from the front-end schematic design. PCB designers can also review and edit signal integrity or high-speed constraints, such as total etch length, in the Constraint Manager worksheets along with other design constraints. The PCB designer can also extract and simulate routed or unrouted electrical topologies using OrCAD Signal Explorer to refine or verify different placement strategies. Signal Explorer can view, refine, and validate constraints on the exported electrical topologies. With a single action, constraint set changes are easily updated back into Constraint Manager from Signal Explorer. Constraint Manager also allows for quick analysis of design constraints to validate against the actual layout as it progresses. When dealing with a large design, the Constraint Manager Audit report can be used to see all constraint violations. The integration of these three design tools, PCB Editor, Constraint Manager, and OrCAD Signal Explorer, provides PCB designers a complete environment to view, refine, and validate constraints and simulate critical placement or high-speed scenarios. PCB designers can extract electrical topologies from routed or unrouted nets. These extracted electrical topologies can be simulated with OrCAD Signal Explorer for verification of the intended design constraints versus the actual layout. Through a couple of straightforward steps, PCB Editor verifies the analysis setup and extracts the electrical topologies from routed or unrouted PCB nets. Upon extraction, the Signal Explorer tool automatically loads the extracted net ready for edit, simulation, optimization, and/or constraint verification. As this extraction is from a routed net, the topology includes the physical trace information. The ideal transmission lines designed in the front-end schematic are now replaced by microstrip or strip line data. Other physical design elements, such as vias on the routed trace, are also included in the extraction. The constraints on the net that were originally set by the front-end designer are available for verification. The same process will extract any net from the design, including differential pairs and clock nets. The integration of OrCAD PCB Editor and OrCAD Signal Explorer provides quick and easy evaluation of physical electrical topologies versus the intended design constraints. As the board is being routed, OrCAD SI provides a number of quick and simple yet powerful board analysis and outputs. The OrCAD SI board analysis tools can quickly run multiple simulations and generate a comprehensive set of reports for evaluation of various signal integrity issues. The OrCAD SI probe function provides a large set of reports that can be generated with the push of a button for the entire board. These reports are easy to generate and provide comprehensive analysis data on items such as crosstalk, reflection, delays, parasitics, and ringing. Signal integrity analysis with OrCAD SI provides a quick and comprehensive final check for signal integrity issues across the entire design and is an essential tool to help achieve first pass success.